All right, dinguses, welcome to our second video for this chapter. Today we're going to talk about solving quadratics by graphing. So it's going to make use a lot of what we did first section on graphing quadratic equations. So let's dive right into this. All right, so what we're going to do today is going to be a combination of last section where we graphed quadratic equations, because obviously we're going to solve by graphing. But what you're going to find as well, and a helpful way to check, is it's going to make use of some things we talked about last chapter. So what I have here is a quadratic equation. I have 0 equals x squared plus 2x minus 3. Okay, so notice that this is equal to 0. Now, we talked about last section in our last video about how to graph this. So imagine this instead of 0, you have y equals x squared plus 2x minus 3. So quickly, let's go through and review how we actually graph this. So the first thing we want to take a look at is what is our axis of symmetry. I'll label that AOS, axis of symmetry. So remember, I gave you a little formula, x equals negative b over 2a. So we're going to look at our equation here, identify what are a, b, and c. So I see that a is number in front of x squared. Notice how this one is 1. So I have a equals 1. B is the number in front of x. I have a 2. And lastly, c is in the last number. I have a negative 3. So plugging our values in, I have negative 2 over 2 times 1. That's going to give me, if we simplify here, it's going to have x equals negative 1. So that means my axis of symmetry is at negative 1. Goes down this value here. Okay? Now remember, axis of symmetry, next thing I want to figure out is where is my vertex. So to figure out where your vertex, and again, the vertex is your maximum minimum point, but my vertex, what I'm going to do is take and simply plug negative 1 into my function. So I want to find, if my x is negative 1, what the heck is my y? So again, plugging it in, I'm going to have negative 1 squared plus 2 times negative 1 minus 3. So simplifying this gives me 1. 2 times negative 1 would be negative 2 minus 3. So evaluating this, 1 minus 2 would be negative 1. Minus 3 would give me negative 4. So I know that my vertex is going to be at negative 1 and negative 4. So that's all the way down there. That's very good. Okay, that's review from the last section we did. Okay, so now what do we do after that when graphing? So graphing, we're going to just create a quick table of values on the side here. Okay, I know that I have a vertex at negative 1, negative 4. Oops, forgot to write the 1. Now what do I do next? Now remember, we have this axis of symmetry, which means that my graph on both sides is going to be equal. That's going to look the same on the right side as it would on the left side. So all we have to do is choose some points on either side of my vertex to graph this. Now, I didn't give you a table this time, but some valuable points to choose would be 1 and 0. So again, if I look at where we have 0, where x is 0 and x is 1, we're going to be able to graph some points here. Okay, so let's do this. Let's plug in 0 and 1, see what we get in our function. I want you guys on your own plug in those values and see what you get. I'm going to have this table filled out in just a second. Alright, so checking quick, here's the points I got from when I plugged in 0. Again, I'm going to get negative 3. When I plug in 1 for x into my function, I'm going to get 0. So I plugged in those values there, now let's plot them. So I know I have a value at 0, negative 3. So I have a value there, or point there, sorry, and then I have a point of 1, 0. Okay? So I know that I have the points there. Now what I'm going to do, again, if it's the same, it's symmetrical, that means if I know one point, if I know the point on this side, I know a point across what we called a reflection. I know the point there. Same thing here, if I know this one, hey look, it's 2 away from the axis, I know I'm going to have 1, 2 away over here at negative 3. So I know right away, okay, once I graph one side, I can graph the rest and sketch my parabola. Now our goal for today is to talk about how to solve. Okay, now I want to go back to our original function. I gave you this. This is something we did last chapter. Is if I give you a quadratic, here's a polynomial of degree 2, and I have this equal to 0. So what we talked about last chapter is something, I'll write it as ZPP, the zero product property. That says if I have two factors times each other equal to 0, I can set them both equal to 0. So what we did last chapter, we factor this. Okay, so I want to look at what are factors of a times c? So factors of 1 and negative 3. So factors of negative 3 that add to 2. Well, that's going to give me x plus 3 and x minus 1. Those would multiply the negative 3, add to 2. Now remember, those are equal to 0. So what did we do next? Well, we took each of our factors, x plus 3, and set it equal to 0, and x minus 1, and set it equal to 0. And here I would get x equals negative 3 and x equals 1. Now, why is this so important? Well, let's take a look at our graph. Notice I have x equals negative 3, x equals negative 1, or x equals 1, I'm sorry. If I look at the graph, x equals negative 3, that's right there. X equals 1, that's right there. So notice when I graph the function, notice when I solved it here and then graphed it and solved, what do you notice here? Well, my negative 3, the x value here, is where my quadratic equation, where my parabola crossed the x-axis. Same thing here. When x equals 1, that is where it crossed the x-axis. Okay, so this is going to bring us up to our main point. Today what we're going to do is solve quadratic equations. Is we are basically going to graph, and what we're going to find here are the 2 points where our graph crosses the x-axis. Now what do we call those 2 points? Where our graph crosses the x-axis. One thing we called this way back was an X-intercept. Okay, I'll write it as X-int, but it's an X-intercept. So what we're going to basically try is graph our function, and then see where our intercepts are. All right, so what do we call our solutions? Now, I've thrown at you many different terms these last couple chapters, but when we solve these functions, we're basically going to get a couple things. Now, what we said just on the last example is that when we graph, what we're going to look at are the x-intercepts. Okay? Notice our x-intercepts were the same thing as our solutions when we solved them just like we did last chapter. Okay? I also mentioned last chapter a term called a zero. So, all these things mean the same thing. X-intercepts, solutions, zeros, they all represent solutions. They all represent where our graph crosses the x-axis. Another name for these is called a root, and that's what we're going to talk about next. It's just another name to represent the solution. So if you ask me or hear me say, what are the roots of this function, I am basically asking you, what are the x-intercepts? What's the solution? Where are the zeros? Okay, they all mean the same thing. X-intercept, solutions, zeros, roots all mean the same thing. It's just different words. We use them at different times. Okay, so let's just take a look at some graphs and see if we can identify some of these points. Now, what I want you to do in each of these is to identify where the roots are, the vertex, and certain things like that. Okay, so I'm just going to throw some different words at you. So roots, we're looking at this first one. Where are our roots? Now remember, our roots are the same thing as our solution. They all mean the same thing. Our roots are going to represent where our graph hits the x-axis. So if I look at this graph, and I know on my screen it's a little blurry, you can probably see it better on your notes, but I see here that my roots would be at x equals, that looks like a 1, and we got x equals 5. Okay, so now one thing I want you to notice is that these are points on a graph. So when I write these, I'm going to write this as 1, 0 and 5, 0. All right, now this brings up an interesting point. Notice that each of these points I have 1, 0, 5, 0. One thing I didn't mention in the last slide is if you notice in both these points, what is my y value equal to? Notice my y is 0. So in all these cases, you are going to find x when y is equal to 0. Okay, so all these roots, intercepts, solutions, zeros, all they represent are values of x when y is 0. Okay, then looking at a graph, what would be our vertex? Okay, so our vertex, again, that's our point down here. Kind of splits the graph in half. What does that value there? It looks like at 3, -4. So I'll write that down, 3, -4. All right, now let's take a look at the next one. Let's find our x-intercepts. What the heck is an x-intercept? This goes back to basic graphing of lines that we talked about a long time ago. X-intercepts, same thing as roots. Don't get confused. Different words mean same thing. They represent the roots, where the graph crosses the x-axis. So if I look at those points, I see I have one at -3, 0, and I have another one at 1, 0. Okay. Now, where's my maximum or minimum point? Okay, so what the heck is a maximum minimum point? Maximum minimum point is your vertex. Okay, why the heck did I call it max and min? Because again, vertex, that's what it means. I can call it something different, but vertex, maximum minimum point, that's the same thing. Okay, it's kind of like zeros, roots, intercepts, they all mean the same thing, just saying it a little different. So what is that value? If I look, I got an x of -1, a y of 2, so my vertex or my maximum minimum point would be at -1, 2, and in this case, it would be a maximum value, because notice how that is the largest value we have if we think of this parabola as being upside down. Okay, last one now, find 0 in the vertex. Here we go. I want you guys to give this a shot. Find the zeros and the vertex. Pause it and go. Okay, so what we see here, this one's a little interesting. Notice how the only intercept that I have is right there at negative 4, 0. So I have one intercept. Now, notice in these two I have 2 and 2 values. In this one I have 1. Now, why do I have 1 where these have 2? Now, here's the difference, and here's why. Notice my vertex is the same exact point. Okay? So when my vertex is my 0, there's how many solutions? One solution. Okay? In this case, I have negative 4, 0. So in this case, I have, where my vertex is my 0, that means I have one solution. So the point I'm going to bring up here is, do you always get 2 solutions? No, you may get 2, you may get 1. Is it possible to be 0 solutions? No solutions. Absolutely. 0 solutions, I'll sketch it on this graph. I want you to think, if 2 solutions means it hits it twice, if 1 solution means it hits it once, what do you think no solution means? That means it's going to hit the x-axis no times. In this case, this graph does not come close to hitting the x-axis, so this would represent no solution. Okay, so that's very possible to see those different things. All right, let's do some examples of solving by graphing. So again, what we're going to do first, just like we did last section, first thing we do is find our vertex. So I look here, right above, my A value is 1, my B is negative 3, and my C is negative 4. So finding my vertex, my axis of symmetry first, I'm going to plug in of negative B over 2A. So that's going to be negative. Now notice here it's negative of negative 3 over 2 times 1. So careful with the signs here. Okay, so what does that give me? Negative 3 would give me positive 3 over 2. So I'm going to get 3 halves, which I can think of 3 halves if I just divide that out as 1.5. So that means I'm going to have my vertex at 1.5, which is between 1 and 2. Okay, now, where is my vertex exactly? Well, the last thing I'm going to do is plug in to my function. Y equals x squared minus 3x minus 4. I'm going to find if my 1.5 is my x value, I need to find my y value. So plugging this in, I'm going to have 1.5 squared minus 3 times 1.5 minus 4. You may need a calculator here. Okay, what's that going to give me? All right, that's going to give me negative 6.25. Now, yeah, I know it's not a very nice number, but that means I have 6.25 there. Sorry for the decimals, but hey, can't avoid them. So that means I have at 1.5, I'm going to look at negative 6.25. So that's just going to be a little bit below 6. So I'm just going to put, do that in red, my point there. Okay? So now what I'm going to try and do is then figure out the rest of my values. So just down below, I'm going to make a quick table of values. We know that our vertex is at 1.5 and then negative 6.25. So what I want to do is I really want to graph the rest of it. So I'm going to choose some values on either side. Okay, I want to choose values on one side. So we could do 2, we could do 3 or 4. Let's choose any values. I'm going to go on the other side actually. I'm going to do 0 and negative 1. Okay, so I'm going to put in 0 and negative 1. I'm going to show it. I can do it on the left side. I could also do it on the right. So if I plug in 0, okay, if I put those values in, 0 squared minus 3 times 0, both those gives me 0. That's going to give me negative 4. So I know I'm going to be at x of 0 and a y of negative 4, so I have that there, okay. And if I plug in negative 1, that's going to give me negative 1 squared is 1. Negative 3 times negative 1 would be positive 3, so I have 1 plus 3 is going to be 4. Minus 4 is 0, so I know that at negative 1, I get a y value of 0, so that'd be there. Okay, now graphing the other side again, if I know one value, I'm going to graph the other, so if I know this one is that value away, notice that this one is how far away? It's 1.5 away, so it's going to be the same distance over here, so where would that be if you think about it? It's going to be at 3. This one is 2.5 away, so 2.5 away would put me over at 4. So I got these values here, then I can sketch it. Question is, what's the solution? Okay, so solving this, we graphed it. Remember, our solution is where it crosses the x-axis. So looking at these two values, I have 4, 0 and negative 1, 0. So based off those two, I have now solved this, and those would be my solution. Okay, one thing to do to check is you can go back and factor and see if you get negative 1 and 4 as your two factors when solving. All right, what I want you to do is follow the same process now, and I want you to solve numbers 2 and 3 here. I want you to do the next two examples on your own. So I want you to pause the video, find the axis of symmetry, find the vertex, make a table, graph it, and then find the 2 points where it crosses the x-axis. So give it a pause and give these two a shot. All right, taking a look here. Solving the second and third one now. A lot of meat and potatoes in this one, folks. So this one might have taken you a while to do, but here we go. So just showing you quickly. First one here, what did I have to do with this one? Okay, now notice what I did is I subtracted 4x to the other side. I needed to make sure it was written in standard form first. So I subtracted 4x, rewrote that so it's equal to 0. Found my axis of symmetry by plugging in negative b over 2a, where b is negative 4, a is 1. So I get negative of negative 4, just like we had here with the negative 3, divided by 2 is going to give me an axis of symmetry at positive 2. Again, then I plug this in, as you can see here, to get my vertex. Vertex right here is at 2, negative 9. So, okay, I get those two things. Now, graph those. And my vertex was right here, 2, negative 9. I plotted my axis of symmetry. Down below, I created a table of values. So I went from 2, and I just decided to choose 1 and 0. Here's what I got. Now, this one's a little tough because when I actually look at these values and I plug in 1, I get negative 8. 0, I get negative 5. So my values that I plotted are up here. So what does that mean? What you might need to do is plot some more values. So if I went to the next one, instead of, if you notice you didn't get close to the x-axis, what might help is choose another value. So choose, maybe go to negative 1 and maybe go to 3 or something like that. And what you should find, even if you plot it correctly, if you just sketch it, you should see it goes around negative 1 and 5. So that means my x-intercepts, negative 1 and 5, that would be my two answers. So negative 1, 0, and 5, 0. So I solved that. I had to sketch and kind of look at it based off of what my sketch was. Now, next one. Same thing here. I moved x squared to the other side. I didn't move these over. I brought x squared here so that it was positive. So remember, we always want this first term to be positive. Found my axis of symmetry to be at negative 3, so I plotted that here. Vertex in by plugging in, I get negative 3, 1. So here's my vertex for this problem. Okay, now, one thing you should notice, vertex is above the x-axis, so that's a little different here. Now, if it was upside down, maybe it would work, but the vertex is above. Plugging into values, I plugged in negative 2 and negative 1 to see what I got, and I got 2 and 5, so I plotted those here. Now, really think about it. Does my graph hit the x-axis? No, it does not. So what does that mean? No solution. So this last one here, a little trick for you, no solution. Okay, so again, this is more graphing. We're graphing here just like we did last section, but now we're kind of combining it with what we did last chapter and trying to find where does our graph hit the x-axis. Remember, we call those zeros, roots, x-intercepts. All those represent the solution to this equation. All right, hope you enjoyed the video, kids. We'll see you in class. Good luck on those practice problems. Peace. I'm out of here.